Welcome back to my channel. This is my fourth video on quadratic equations. For this video I have selected question number 6, which was given in 2016 O-level past paper. First let us read this question. They have given a rectangle and they have separated this rectangle into 4 parts. The question says the part capital P obtained by cutting a rectangular metal sheet of length 4 meters and width 2 meters along two straight dashed lines as shown in the figure is a square. So figure is divided into 4 parts using 2 lines, and they have marked a section P and section Q. Section P is a square and they have taken those dimensions as x. Side length of part P is x meters. Under Roman number 1, they are asking find an expression in terms of x for the area of the rectangular part labeled Q in the figure. So we have to find the area of section Q of this metal sheet. So from the diagram we have to identify the length and breadth of this Q section. So area of Q will be, length is, entire length of the metal sheet is 4. Length of a side of section P is x. So length of Q will be x minus 4. So we have to subtract x from 4. Similarly, we can take the breadth. Entire breadth of the metal sheet is 2. Breadth of that section P is x. So we have to subtract x from 2 to obtain the breadth of part Q. So when we just simplify this, we can get an expression for Q. So this is enough for the answer of Roman number 1. Roman number 2. The area of P is twice the area of Q. So they have given a relationship for the two areas of P and Q sections. From that we have to show a quadratic equation. Show that x squared minus 12x plus 16 equals 0. So that we have to consider that relationship, area of P. So what is the area of P? It is a square of side length x. So area will be x squared. Is twice the area of Q. So what was the area of Q? This is that expression. But they are saying this area is equivalent to 2 times this area. Once again I will read that part. The area of P is twice the area of Q. This is the area of Q, twice. Now we can simplify this. This becomes 8 minus 2x within brackets. Again we have to remove these 2 brackets. This becomes 16 minus 8x minus 4x plus 2x squared. And since this x squared term, coefficient of x squared term is 2, we will take this x to this side. And when we simplify this and this, we get plus x squared in right hand side. And when we simplify these two like terms, we get minus 12x plus 16. Left hand side becomes 0. Standard way of putting 0 is in right hand side. Now this is the equation they want us to show in Roman number 2. Roman number 3. Using the formula or by some other method, show that x equals 6 plus or minus 2 root 5. So we have to simplify this quadratic equation. For that I am using completing square method. In that method, first step is to check whether there is a coefficient for x squared term other than plus 1. So this is plus 1. If there was a coefficient for x squared term, let's say we had 2, we have to divide all these terms by 2 to make this coefficient plus 1. Since we have plus 1 in the quadratic equation, no need to do that. As the second step, we have to shift this constant term to right hand side by changing its sign, becomes minus 16. Third step is to identify the coefficient, but only the numerical value of x term, that is 12, and divide it by 2. Answer is 6. Then we have to take the square of that answer, which is 36. So we have to add this number 36 in both sides. For these three terms, we can construct a perfect square. How to identify or how to fill the two terms of this perfect square? First, take the square root of x square, that is x. Take the square root of 36, that is 6. And take the sign of the middle term and put it in the middle. Here we get plus 20. Take square root in both sides. This becomes plus or minus root 20. We can write root 20 as 4 times 5. Square root 4 is 2, and this is 2 root 5. So x minus 6 becomes plus or minus 2 root 5. So we get the solution for x as, when we shift minus 6 here, it becomes plus 6, plus or minus 2 root. This is the answer for Roman number 3. Roman number 4. Show that the value 6 plus 2 root 5 is not suitable for x. Here we have obtained two solutions for a unknown term x. That can be 6 plus 2 root 5 or 6 minus 2 root 5. But in this question they are asking to show us 6 plus 2 root 5 is not suitable. For that we have to consider an appropriate length in terms of x. So these are the two lengths having x. So this is the length of section Q, this is the breadth of section Q. So I can take any length. So I take length, which is 4 minus 6. For that I am going to substitute the solution that they want us to show not suitable, that is 6 plus 2 root 5. So I substituted this for x. When I simplify, I get minus 6 minus 2 root 5. 4 minus 6 is minus 2. This is the answer we get for this length of Q. See, this entire value is negative, minus 2. Whole number is minus, this irrational number, that is also minus. So we can't have a negative answer for a length. So according to that logic, we can say this solution which we substituted is not suitable. Why? The length became negative. Length cannot be negative. Therefore, solution 6 plus 2 root 5 is not suitable. Problem number 5. By taking the value of root 5 as 2.24, value of root 5 as 2.24, find the suitable value of x. So suitable value, if this is not suitable, suitable value for x is 6 minus 2 root 5. Then we have to find the value of x by considering root 5 as 2.24. When we multiply, we get 4.48. After simplifying 4.48, we get the answer as plus 1.52. So this is the length. We got a positive answer. In the question, they have given the value of x in meters, so we have to substitute the unit 1.52 meters. With that, I conclude this question 2016 quadratic equation problem. See you from another video.